Good evening, YouTube. This is diveflyfish. This is the galvanic cell that I made again with the 2 pieces of magnesium, the PTFE tape, and the water and galena. So this is the voltage that's registering right now. What I'm going to do is we're going to do the same test with the Endo Cool refrigerant to see if we have the same type of current levels and deterioration and or bouncing back or jumping up as we found with the ostensibly crystal type cell. So here we have a very similar milliamp output using a completely liquid electrolyte located underneath this band here. And let's see what happens. So we're going to expose it to the same coolant and we'll watch the current levels. Again, this is on the milliamp hour level and we'll see what it does. Here we go. So it may drop off more precipitously. 14. So we're not seeing the jump. I'm going to hit it with an extended range just like we did with the other one. Now we're seeing a little bit of a jump, but not much. The more I spray it, it's seemingly stabilizing right about at that milliamp hour. So again, that thing is just frozen solid. Completely frozen solid, and that's the milliamp hour there. So again, this is acting differently than the zinc oxide based battery. Now I'm just going to let this warm up and we'll see if it continues to drop or it continues to go up. It looks like it is climbing back up ever so slowly. So freezing a galvanic cell solid still allows for some ionic movement, obviously, but it dropped much greater than the other zinc oxide type cell. So again, I find this encouraging. Have a great night. It's diveflyfish. Here I have my OREO cells that I have shorted out for the last 4 days. What I'm going to do is we're going to remove the copper wire shorting bar there, and we're going to see if we see any form of voltage bounce back. So we'll get this set up and we'll do this one here first. So I'm just going to remove the copper shorting wire and I'll set this so that it's hopefully touching there to maintain contact. Let's see how I can do this. 1 second. I'll just do it by hand here first. So suffice to say, I'm just going to hold this contact on it. What we're seeing here is a bounce back effect. With this dry carbon-carbon OREO cell. And you can see the voltage is climbing. Now granted, this is not a super large voltage, but remember we have 2 identical electrodes. It's been shorted for 4 days. I'm not adding any thermal variance on this, and the voltage is rising. Where it goes to I don't know, but I'm holding this with one hand and I'm not able to really tell you at this point where it's going. So suffice to say, this material that I'm using as an interface, the zinc oxide, Epsom salt, galena, iron pyrite, etc. mix, has a property to it that I would say unequivocally is non-galvanic, because I have not added any water to this cell system and the voltage is climbing even after being shorted for 4 days solid. So this is a dry system. Whatever is trapped in that solid electrolyte has not been re-imbibed or otherwise. So again, you can see the clear indication here of voltage rise even after dead shorting for 4 days. And again, just to show you, this material here is like a rock. Okay? So that was test cell OREO number 1. Move this out of the way here. Again, just to give an example, that's what it looks like. 2 pieces of carbon obtained from United Nuclear Supply, and that is the dry material. Would not recommend eating this, but it seems to work, and not as a capacitor. And again, what I did was simply use a piece of copper wire as a shunting short, like I have here on this cell. Now, this is test cell number 2 that I've hooked up to this voltmeter. I'm simply going to remove the shunt and place this wire here and watch to see if we see the same effect. The only difference is I sprinkled some titanium dioxide on the outside of this carbon. So I originally was going to grow another layer of cells on top of this and make a pile cell, but I decided not to do that. So that was just residual. And I'm going to put this wire electrode here, and we'll see if this one too rises. This one appears to be more stable, not rising to any great extent. See if I can bend this so I don't have to hold it there. There we go. Alright. It's moving. Hold on. Just see if I can hold it in position better. Maybe it is rising ever so slightly. If nothing else, it didn't kill it, which I, at the very minimum, find fascinating. And again, more research needs to be done on this material. I'll try a different spot on this just to see if that makes a difference. 0.9, 8.9. I'm going to try a different multimeter entirely. Let's try this one here as well. So here is the multimeter I used from the other one. That one. Let's try that. So I'll place this electrode here on the top. I'm going to put this down right here. Should mind moving around here, folks. I'm going to photograph this with one hand. It's not easy to do. Let's see here so you can see it. 0.9. .10. Maybe it is rising. Maybe it just matters where you hold it on the cell. Try a different area here. 10. 9. So in any event, the material didn't die. So it'll be interesting to see after sitting again for a day or so if they both bounce back. And again, the first cell that I showed you after shorting what that was, and now we'll test it again just after sitting for a couple more minutes by itself. See, yeah, it's gone up, depending upon where you hold it. For sure. So there is some regenerative capacity to this, even in the carbon-carbon cell form. So for what it's worth, I think we need to keep on pursuing this perhaps. Any and all thoughts are welcome. Have a great night.